Alright, so let's look at that little reading guide that gave us information regarding sussing normality. Now, what that's referring to is the fact that we've read all of these different problems thus far, and they've told us in the process, hey, this thing is approximately normal. Use the normal distribution to solve the problem. These things are normally distributed. And of course, the question becomes, how does one know that is the case? Well, one of the more basic things that you can do is graph the data. A normal distribution has what type of shape? So we would expect that if we graph a histogram of data that has been collected for whatever the topic happens to be, that it should look like a bell-shaped distribution. We could, of course, also graph the box plot. That represents equal widths to make an indication of a bell-shaped distribution. The problem, of course, becomes, number one, histograms are very temperamental in that, depending on your class width, how many classes you choose to have, that can change the way your histogram looks. So you might have it set up so that it looks perfectly bell-shaped, but if you make a slight change to your class width, the histogram looks completely different. The other issue, of course, is data sets. When you're collecting data, there are times when you just not have enough data. And so as we read there on page 382, small sets of data cause a huge issue because they do not give us enough pieces of information to create big enough classes, to create enough classes to make a histogram that really has a good shape. And we've seen that before in our own examples where just a few numbers in the set of data, you end up with just a couple bars, you really can't tell, is it in the center, is it skewed, it doesn't make a whole lot of sense. So addressing these issues, people try to identify some kind of way they can use to decide if a set of data is normal without just relying on graph. And so they came up with this idea of a normal probability plot. We can see some graphs here in the textbook on page 384 is a good one. These are graphed in our textbook using a statistical software called Minitab. And so you can see the graph has some points. There's kind of a line in the center, and then there are some little swingy, curvy things on the outside. Those points are correlated to the normal score for our data points instead of data. The normal score is basically what we would expect the z-score to be if this set of data is normal. So they go through a little calculation, they make all these normal scores, and then they graph them. So like I said, on page 384, there's one here in figure 34, and we have a very small set of data represented. Would this represent a normal situation? Well, what are the requirements? What are we looking for on a normal probability plot? Well, we expect that if we graph these normal scores with the set of data, we should get something that looks fairly linear. And so Minitab puts that line on there that represents the perfect linear relationship that we would expect. And then they also put those bounds on, so they know everything's not going to be perfect. It is the real world. And so they say, okay, it should be right along this line. We can understand it might deviate a little bit. Here are some bounds within we need to stay. And so if you look at figure 34, do they make a line? Obviously not a perfect line, but it's kind of linear, okay? Moving in a positive direction. Are all of the points within the two little squishy bounds? Yeah. So that represents a normal situation. Comparatively, if you look at the normal probability plot on page 385, much larger set of data in this case, does that one in figure 35 represent a normal situation? No. There's clearly a curve to it. There are lots of points that are outside the bounds that the program has created, so this is not what we would consider a normal situation. We do not generally graph these things by hand because that's just a pain in the butt. to use technology to help us out there. And so that's why we pulled out our calculators today, because they will as well graph probability plots, which is pretty sweet. So you should have the information there regarding the number of customers that come to the auto repair station already in your information. Hopefully you've given it a title at the top as well. And so we can check this set of data. We can check this set of data looking at the graphs. We can then also look at the normal probability plot. So of course, to do any graphing, we're going to have to go to our data and statistics page as we've done before. Which is that. And of course, we also need to tell it what set of data we're graphing. So click to add your variable there at the bottom. And then, of course, we can change it into a histogram. Let's see what this histogram looks like to start out. What shape might we refer to this as? Okay, maybe a little skewed left. The ones on the left are a bit shorter. It could be bell, because the peak, if you will, is towards the center. There's only 6 bars, so it is at the 4th bar, so it could be considered bell as well. Clearly not absolutely symmetric, but could be all right. So again, it's a little unclear. We only have 6 bars to work with. We change the bin settings, change the class width. That could change things dramatically. Let's check out the box and whisker plot. That tells us about something that is symmetric. So let's change it over. Oh, right. Okay. Box plot. What appears in this case, I mean, both the boxes seem to be about the same size. Both of those boxes are about the same size as the right whisker. The left whisker is a smidge longer. So maybe a little skewed left. If it is skewed left, is it skewed left enough that we can't use the normal distribution? I don't know, it was kind of bellish too. Well, the final answer, of course, comes from the normal probability plot. So probably by now you noticed in the plot type menu, there's also the option for normal probability plot. So that's the one we're talking about that is new here. And so unfortunately, the calculator doesn't draw the nifty bounds around the outside, but it does give you that line that we would expect our data to lie along. I just want to plot type and change it to a normal probability plot. So you can definitely see if it follows the linear pattern. You can kind of imagine where those bounds might be. There's a little wiggle room for your points. So what do we think? Yeah, this one follows the dots pretty well. Follows the line pretty well. The bounds, of course, would come in, and they come in, so you get a little bit more wiggle room on the end. So that one looks pretty normal. Pretty good representation of a normal distribution. So even though it might have a little bit of space to it, I think I can still use the normal distribution and be able to calculate probabilities that are valid. Everybody good on creating the normal probability plot? Now we have that second set of data that we entered, this one regarding the school loans. We can actually just change the data set. We have to go through a whole bunch of steps. So we can just change this to whatever you call the loan information at the bottom. So just click to add the other variable at the bottom. Let's see what you get there. Oh, okay. So, what do we think about this one? Yeah, definitely has a curve to it. If we imagine those bounds on there, maybe not. These ones fit. This one would definitely be outside. So this student loan information does not represent a situation for which we could use the normal distribution. If we did choose to use the normal distribution, yeah, we might get some answers, but they're not going to be particularly valid for this set of data. If you take this opportunity, then let's take a look at the graph, see what it looks like. Oh yeah, seriously skewed right. So this one would definitely not be a situation where the normal distribution would be a good choice. Questions? So, bottom line is, we use these normal probability plots to be able to tell us whether our set of data represents something that is normal. We can use those then to decide if we want to use the normal distribution to create probability proportions for our information. Our homework site is on the same topic, so there's the normal probability plots drawn there in the book, and you get to decide whether they're normal. At this point, we will transition over to our other topic for today, which is dealing with some other types of normal distribution questions. So if you will turn over to page 378.